Hello, 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 hello. Can you hear me, students? Hello, 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 hello. ಎಲ್ಲ PU2 ಸೈನ್ಸ್ ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಷ್ಟ ದೇವತೆಗೆ, ಗುರು ಹಿರಿಯರಿಗೆ, ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆಯನ್ನು ಸಲ್ಲಿಸಿ ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿ ಇಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ, ಗುರು ಹಿರಿಯರಿಗೆ, ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆಯನ್ನು ಸಲ್ಲಿಸಿ. ಟೇಕ್ ಎ ಡೀಪ್ ಬ್ರೇತ್ಸ್. Yes, good morning, my dear students. In the previous class, we'll continue the chapter solutions today. Solutions. Yes, in the chapter solutions, we studied already the first topic, the introduction part of solutions, and also in the last week we completed units of expressing concentration. Units of expressing concentration. Units of expressing concentration, that is the mass by mass percentage, mass by volume percentage, volume by volume percentage, how to calculate, and even molarity and mole fraction. Okay, and we started learning the solubility. The third topic, solubility, we discussed. In the solubility, we studied the solubility of two cases. One is the solubility of solid in liquid, we discussed. Right? And second one is solubility of gas in liquid. Solubility of gas in liquid. And we were to introduce the Henry's law. That is, suppose that in the case of solubility of solute will be in a gaseous state and the solvent will be in a liquid state, say water, liquid state. Then obviously it is there is a dynamic equilibrium we discussed. A solution will be in the liquid state. See here. So gas is when dissolved in water, it's like condensation. When dissolved in water, condensation. See, evaporation is endothermic, condensation is exothermic. Therefore, when a solute is a gas dissolved in water, this particular process is dissolution in water. And when the gases come out of it. This particular thing is called as evaporation. Again, this is always said that always exothermic means heat energy is liberated. Exothermic, the reaction is exothermic because condensation reaction is exothermic. Exothermic. So this particular law was studied, this particular dissolution of gases in liquid. Case 2, solubility of a gas in liquid was studied by Henry as well as Dalton. Finally, we arrived at a particular result that, right, the partial pressure of a gas, partial pressure of a gas in liquid, the partial pressure of a gas on the surface of the liquid, the partial pressure of a gas on the surface of a liquid, is directly proportional to the mole fraction, directly proportional to the mole fraction of the gas in a liquid, gas dissolved in liquid, mole fraction of the gas dissolved in liquid at a given temperature. Because as the temperature changes, we discussed in the last class, at given temperature or constant temperature. At a given temperature is the statement of Henry's law. Try to understand. The partial pressure means, suppose that you take air. Air consists of the mixture of different gases. Very gases, nitrogen, carbon dioxide, oxygen. Air consists of different gases. Among them, when oxygen, if you consider in particular, then comes the partial pressure. The partial pressure of a gas, the partial pressure of a gas on the surface of a liquid is directly proportional, means increases to the mole fraction of the gas dissolved in liquid at a given temperature. Mathematically, so this is the final statement of the Henry's law. Today we will see some numericals also on Henry's law and study of the Henry's law constant. So, right, we said that this particular partial pressure of a gas P is directly proportional to mole fraction of that particular gas. If you remove the proportionality sign, you know that mole fraction is represented by chi, and you will get a constant called as Henry's law constant. This particular Kh value is called as Henry's law constant. So this particular Henry's law constant depends upon, it is a constant. Henry's law constant is a constant dependent by Kh. It is a constant for a given gas at a given temperature. It is a constant for a given gas. First point is, for a given gas, for different gases it will be different at a given temperature. And already we discussed why it depends on temperature. The Kh value, what happens here, if for a Kh value, observe here, take chi to the left, right? If higher the value of KH, you observe here, this shows that Henry's law constant is inversely proportional to what? Mole fraction, partial pressure. Means as the partial pressure of the solubility, partial pressure means solubility. Solubility increases as the KH value decreases. Solubility decreases as the KH value increases. Means higher the value of KH. Remember, higher the value of Henry's law constant, higher the value higher the value of KH, right? Lower will be the solubility. Remember, this mole fraction is solubility. Lower will be the solubility of gas. First point you have to remember. Logical questions will be appeared. Higher the value of KH, lower will be the solubility of the gas. In other words, it is inversely proportional. And vice versa. What is vice versa? What is the meaning of vice versa? Vice versa means lower the value of KH value, then higher will be the solubility of the gas in liquid. And effect of temperature we discussed. So as the temperature increases, what happens to the solubility? As the temperature increases, you know that it is forward reaction is exothermic. Then as the temperature increases, to nullify the effect, the dynamic equilibrium shifts to the backward direction. As the temperature increases, solubility, backward reaction means solubility of gas decreases. Solubility of gas decreases means more evaporation takes place. Decreases, sir. More evaporation takes place. So it means that as the temperature increases in the summer season, that is the reason some practical applications we are discussing. So practical applications of Henry's law are very important. You may be asked some questions based on practical applications. What will be asked is, first question is, why aquatic animals feel suffocation or even die in the summer season? Summer season, what happens is, because the aquatic animals survive. Remember, aquatic animals survive. Okay, aquatic animals survive. Aquatic animals survive using oxygen of atmosphere dissolved in it, very small quantity of oxygen atmosphere, using oxygen of atmosphere dissolved in water, in water body, maybe ocean, maybe river, water body like fish, water body. But in summer season, what happens is, in summer season, what happens? In winter season, what happens? You can think and tell me. In summer season, what happens? Forward reaction is exothermic, therefore backward reaction takes place. Therefore, dissolved oxygen will leave the surface. Hence, deficiency andre oxygen evaluates. Oxygen gas ಏನಾಗ್ಬಿಡ್ತದಂದ್ರೆ oxygen evaporate ಆಗ್ಬಿಡ್ತದೆ. Oxygen evaporate ಆಗೋಗ್ಬಿಡ್ತಂದ್ರೆ they feel what? Suffocation. Oxygen evaporate, therefore they feel suffocation and they will die. In winter season, what happens is solubility what? Right? More oxygen is soluble because in forward reaction will be exothermic. As the temperature decreases in winter season, In summer season, temperature increases. In winter season, temperature decreases. As the temperature decreases, backward reaction takes place. Because backward reaction is forward reaction takes place. Because when the temperature is decreased to attain the equilibrium back, and exothermic reaction should take place. Therefore, the equilibrium will be shifted to the right. So therefore, more oxygen is dissolved. More oxygen is dissolved. This is one application. More oxygen is dissolved. Hence, they feel comfortable in aqueous solution. Some practical applications of the Henry's law, or the, you can say, okay, the temperature, effect of temperature, right? Effect of temperature we discussed. So another example we can give is, in the beginning only I told you that a soda water bottle. What is soda water? The soda water bottle, right? Here you cannot observe any bubble. It is nothing but a soda water bottle. Whenever you feel indigestion, you drink soda water bottle. No? Therefore, in soda water bottle, carbon dioxide gas is dissolved under high pressure. Under high pressure. Look at here. High pressure. What is the effect of pressure on the solubility of a gas? When the pressure increases, solubility increases. That is what the Henry's law tells. Partial pressure of oxygen is directly proportional to the mole fraction of the oxygen dissolved at a given temperature. Means higher the pressure, more will be the solubility. Therefore, at high pressure, carbon dioxide will be dissolved in soda water bottle. Once you open it, say here inside the atmosphere, at 4 atmosphere it is compressed. Now, once you open the bottle, outside the soda water bottle, pressure is 1 atmosphere. Therefore, pressure decreases. When the pressure decreases, solubility also decreases. Therefore, carbon dioxide gas is dissolved in it, will bubble out and come out. Therefore, you observe the bubbles whenever you open the using opener, when you open the soda water bottle. I hope the things are clear at you. So that is Henry's law. Try to understand some applications based questions will appear on Henry's law, dear students. You observe it and note it down. Second application is deep sea divers, scuba divers, deep sea divers. See, deep sea divers, they generally go deep in the under the ocean. Observe here, as you enter, deep sea divers, scuba divers. So as you go to the deeper layers of the ocean, high pressure will be there. Pressure goes on increasing. Pressure increases. Clear to you? So therefore, when they go to the deeper layers of this particular ocean water, more and more pressure increases, right? So therefore, atmospheric air, if it is filled, the pressure, as the pressure goes on increasing, once again I will tell you, as the pressure of air, so pressure under the water is directly proportional to the mole fraction of the oxygen, carbon dioxide, nitrogen, all will be present in the air. Is that clear to you? So in the deep sea, as the pressure increases, the dissolution of this, especially the nitrogen, will increase in the body. So once they come out here, as they come out of the water, so in the capillaries, due to the high pressure, the gaseous nitrogen will be dissolved in it. So that nitrogen, once the pressure, suddenly when they come to the upper layers outside the water, air pressure becomes 1 atmosphere. When they come out of water, because under the ocean, Due to the high pressure, more nitrogen, more carbon dioxide, oxygen will be dissolved in it. When they come out of water, the pressure becomes what? 1 atmosphere, suddenly decreases. When the pressure decreases, what should happen to the dissolved gases will come out. So during the process, in the capillaries of the blood vessels, what happens is the nitrogen gas comes out suddenly. They will have a very painful sensation, painful sensation during bubbling out of dissolved nitrogen in blood capillaries, dissolved nitrogen in blood capillaries. They will have a painful sensation. This particular situation is called as bends. Remember, this is called as bends. And sometimes it may even lead to death also. Therefore, the remedy for this bends is note down clearly, my dear students. Number of times questions appear. In the gas cylinder, they are carrying in the gas cylinder to dilute it. In the gas cylinder, to prevent this bends effect, it is diluted with three gases. Generally, nitrogen percentage in the air will be high. Therefore, the gas cylinder will have 11.7% helium, note down correctly, 56.2% nitrogen, otherwise in the air it will be 70, and helium will diffuse and make it dilute, and 32.1% oxygen will be filled in the cylinders. And if these ratios you remember, number of times questions appeared. In the cylinders used by the scuba divers, 11.7% of helium, 56.2% of nitrogen, 32.1% of oxygen is filled in this ratio, then the effect of bends will be lowered. So this is one practical application of the Henry's law. I hope you understood what is bends. Once again, let me repeat you. When deep sea divers go into the deeper layers of the depth of the ocean water, due to the high pressure there, as the pressure increases, what happens? The more and more nitrogen, because nitrogen is percentage 70% is dissolved in blood, and at high pressure, when they come out of the water body, so suddenly the atmospheric pressure becomes 1 atmosphere. When it suddenly decreases, the backward reaction takes place, and dissolved nitrogens from the capillaries in the form of the bubbles will come out. During the process in the entire body, the deep sea divers will feel a particular painful sensation that is called as bends. The remedy to avoid the bends is, you have to, generally the cylinders used by the deep sea divers or scuba divers will be 11.7% helium, which will diffuse it, lower the pressure, 56.2% of nitrogen, 32.1% of oxygen will prevent from the bends. That is a second application of it. And another application we'll see now. As you go to the in hill stations, like if you go up in hill stations, if you go, for example, Mount Everest, if you are climbing, so in the upper, as you move, this is the troposphere. Observe, troposphere. What happens is, in the atmosphere in which we are living is troposphere, the first sphere where weather phenomenon takes place, troposphere. As you move upwards, what happens is the concentration of air decreases. Concentration of air decreases. concentration of air decreases. Means when the concentration of air decreases, what happens is the pressure of the air will decrease. When the pressure of the air decrease, that person climbing, mountain climbers, like Mount Everest, mountain climbers, will feel the deficiency of oxygen. Then their mind do not get sufficient oxygen, then they will have lesser capacity, can't think clearly, and they feel uneasiness clearly, can't think clearly, they feel uneasiness. This particular situation is called as anoxia, and they feel weaker, can't think clearly, and they become weaker, right? This particular can't think clearly, and they feel weaker, and such a situation is called as anoxia. What it is called as anoxia. Observe some of the applications. You will be asked, what is anoxia? Anoxia is a situation. So when experienced by mountain climbers in the upper in the upper layers of the atmosphere, concentration of oxygen will be less, and therefore due to as the pressure decreases due to the lack of oxygen, they can't think clearly and they feel weaker, and such a situation is called as anoxia, right? And this is called as bends, therefore they will carry oxygen cylinders. So these are some of the applications of Henry's law, and values of the Henry's law can be calculated, right? And some details or values are given in your book also, based on the KH value is a constant at a different temperature for different gases, right? So based on that we will see a few questions. Okay, few questions on it. Take one question. Dry air consists of, we'll solve some problems on Henry's law. Definitely some 2 mark questions may appear. We'll solve. Dry air contains, take first problem. Dry air contains 79% is nitrogen, 21% is oxygen, 21% is oxygen. Determine the proportion. Determine the proportion. So determine the proportion of nitrogen and oxygen. Determine the proportion of nitrogen and oxygen dissolved in water. At 1 atmospheric pressure. At 1 atmospheric pressure. Observe. At 1 atmospheric pressure. Henry's law constant is constant for nitrogen and oxygen, for nitrogen and oxygen are 8.54 into 10 raised to 4 atmosphere and 4.56 into 10 raised to 4 atmosphere respectively. Look at the problem. Let us study the problem respectively. See, so what is dry air contains 79% of nitrogen, 21% of oxygen. Determine the proportion of nitrogen and oxygen dissolved in water at 1 atmospheric pressure. So given determine the determine the proportion of nitrogen and oxygen dissolved in water at 1 atmospheric pressure. Henry's law constant for nitrogen and oxygen are 8.54 into 10 raised to 4 atmosphere. Look at here. What you are given with, you have to note down what is given. Given that percentage of nitrogen is equal to 79. Then the percentage of oxygen is 21%, 39%, 21%. And KH value of what is the first one? Nitrogen is given, it is given as 8.54 atmosphere. 8.54. What is the unit of because it is a KH value 8.54 atmosphere is in the unit of the pressure only. KH of oxygen is given by oxygen is given by what? Oxygen is given by 4.56 into 10 raised to 4 atmosphere. 4.56 into 10 raised to 4 atmosphere. Now, what is the solution? You are asked to find out. What you are asked to find out? You are asked to find out, this is given. Proportion of nitrogen and oxygen dissolved. Means, proportion of nitrogen and oxygen dissolved is the thing but what? Proportion of nitrogen and oxygen dissolved is the mole fraction of nitrogen is to, that is mole fraction of nitrogen is to mole fraction of oxygen. You have to find out. What is Henry's law? Solution. Let us solve it. According to Henry's law, what is the formula? Henry's law. So mole fraction of nitrogen is given by KH of nitrogen into, partial pressure of nitrogen is given by KH into mole fraction of nitrogen. Similarly, partial pressure of oxygen is given by KH into mole fraction of oxygen. Now you are asked to get mole fraction of nitrogen. KH values are given. You have to find out what? Partial pressure of nitrogen. How can you get the partial pressure of nitrogen? They have the ratio 79. For that, what is the formula of partial pressure? Number of moles of nitrogen divided by number of moles of nitrogen plus number of moles of oxygen. That is water. Water is a solvent here. Nitrogen is dissolved in water. Water is a solvent here. Do you agree with me? Then how can you get? Right? Partial pressure of nitrogen is given by, it is 1 atmosphere. See, what is the pressure? Pressure is 1 atmosphere. Right? So, pressure is 1 atmosphere. Of that means 100. In 100, 79% is the pressure is 1 atmosphere. Total pressure is 1 atmosphere. Some of the partial pressures will be equal to. Some of the partial pressures of nitrogen, that is mole fraction of nitrogen plus mole fraction of partial pressure of nitrogen will be, what is the percentage? 79%. In 100 mole, nitrogen consists of 79 mole, then in 1 mole you will get 0.79 atmosphere. That of oxygen is, this is 21 upon 100, you get what? 0.21 atmosphere. Because the total pressure is 1 atmosphere, you can take it as 0.79, 0.21 will be 1 atmosphere. Now you can get the mole fraction of nitrogen is given by, you can take a partial pressure of nitrogen divided by KH value. Partial pressure of nitrogen divided by KH value. Now you can get now partial pressure of nitrogen is given as 0.79 atmosphere divided by KH value of nitrogen 8.54 atmosphere. Just to divide it, you will get the answer. Use the calculator. Calculate the value. Calculate the value. You can use simple calculator. 0.79 divided by 8.54 is equal to, you will get here 0.0925. 0.0925. It is 8.54, into 10 raised to 4. Please check it. Into 10 raised to 4, into 10 raised to 4. Into 10 raised to 4. And you can write it as 0.0925 into 10 raised to minus 4. Shift. To write it in a scientific notation, the shift decimal point to the right shift, you have to subtract. To shift it to the right, you will get the mole fraction of nitrogen will be 9.25 into 10 raised to minus 6. Right shift to subtract, minus 4 minus 2. Similarly, mole fraction of oxygen is given by 4.56. It is given by 21. Isn't it? The formula is a partial pressure of oxygen upon KH value. What is the partial pressure of oxygen is? Partial pressure of oxygen is 0.21 atmosphere. Out of 1 atmosphere, you can easily calculate. KH value of oxygen is 4.56 into 10 raised to 4. Right? You can take 10 raised to 4 to the numerator and calculate the ratio. Again, you will get 0.21 divided by 4.56. You will get here 0, that is 0.0460 into 10 raised to minus 4. You shift 2 decimal places to the right. You will get 4.60 into 10 raised to minus 4 minus 2 is minus 6. Mole fraction has got no definite thing, means unitless. Therefore, ratio of mole fraction of nitrogen divided by mole fraction of oxygen, you can calculate now and write the value. You can calculate now and write the value. Mole fraction of nitrogen is 9.25 into 10 raised to minus 6. 9.25 into 10 raised to minus 6 divided by 4.56. 4.56 into 10 raised to minus 6. 10 raised to minus 6, 10 raised to minus 6 cancels. You can take the ratio approximately 9.25 divided by 4.56. This comes out to be very, very close to 2/1. Therefore, mole fraction of nitrogen is to mole fraction of oxygen will be equal to 2:1. I hope you understood, my dear students. Okay. Right? Okay. That's all for today. Tomorrow we'll take a little bit more time. Today I was late night I came. So tomorrow sharp at 6:45 will continue. And in the next class, we are continuing solving the paper I sent you. I sent you already the paper in the WhatsApp group, inverse trigonometric function. That paper I will solve tomorrow. Right? We will discuss that paper, and I expect you to come on live stream, and we'll discuss the paper and send your marks to me along with your paper. Okay, that's all, my dear students, today. Bye bye, see you.